Now, today we will continue with our discussion about logarithm equations, but now we will see examples when we have logs on both sides of the equations. Now, when this is the case, the computation actually becomes more manageable because when you have logs with the same base equal to each other, they will cancel out. What do I mean with this? Well, let's see some examples, but just remember that the main idea for today here is that log with same base will cancel out when they're equal to each other. So that's the main idea for this lesson. Now, let's look at an example. Look at example 1 here. Just by looking at it, it looks a little more intimidating because now you have both logs and you have a log on the left side and a log on the right side. But what do you notice here? Notice that here the logs, they have the same base. Remember, if you don't see a base there, there's always base 10. Both of them have base 10. They're equal to each other. So what ends up happening is just that they will cancel each other. So now, what you have now is just 5x equals 2x plus 9. And then we just solve using our Algebra 1 skills. Again, this is only possible if the logarithms are equal to each other, there's an equal sign between them, and they have the same base here. If they do, they just cancel out, and now we just set what's left off equal to each other. So here, let's use our Algebra 1 skills to solve for x. So let's subtract 2x here. Subtract 2x. So now we have 3x equals to 9. You want to solve for x? Well, you're just one step away. So this is just x is equal to 3. Notice that what we're doing here, we were solving, and to solve is to leave the variable by itself. So let's look at our next example here. Now here we have example 2. Okay, so now we don't have 1 or 2, but we have 3 logarithms. So how do we solve equations that have 3 logarithms? Well, when you're solving, your problem is going to be more manageable if you decide to simplify, you decide to condense your logarithms. What do I mean by that? Look at the left side. Here, on the left side of the equation, I'm adding 2 logarithms. Here, I'm adding these 2 logarithms here. But what do you know about addition of logarithms? If you can condense it, you know that adding is multiplying. So let's rewrite the left side. So the left side, we can rewrite it as just log of x times 7 equals log of 37. Well, we know that x times 7 is the same as 7 times x, which is the same as 7x. So let me just rewrite what's inside the logarithm as just 7x. Okay, so we have 7x now. So what do we have here? Notice we have 2 logarithms now. So we went from 3 logarithms to 2 logarithms. Notice that they have the same base. Again, if you don't see a number underneath the log, there's always an imaginary 10 there. They're equal to each other, so they cancel out. So now what we have is the following. Now, we just have 7x equal to 37. We want to solve for x, so we divided 7 to both sides, and we're done. So let's circle our final answer here. So we know that x is equal to 37 over 7. I like to leave my answers in fraction form. Now, let's look at example 3. Okay, so first thing that you want to do is, should I condense it? Do I have more than 2 logarithms? No, I have 2 logarithms. They're equal to each other. So what's going to happen with them? You need to make sure they have the same base. Again, if they don't have a base, there's always a 10 there. They're equal to each other, same base, boom, they cancel out. We're done. So now we have 10 minus 4x equal to 10 minus 3x. Excellent. So what can we do here? Well, let's take away 10 to both sides. Because if we do that, they will cancel out. And now we have 4x equals negative 3x. Let's put the x's on the same side. So let's add 3x to both sides. So now we have negative 4x plus 3x, let's use negative x, equal to 0. So let's divide by negative 1. You can kind of already see the answer here. We can see that x is equal to 0. That's it. That's pretty much it. So finally, let's look at our last example here. Example 4. Okay, so you have 3 logs now. Try to see if there's a way for you to condense it. Notice on the left side here, this side, you can compress it, you can condense it. How? Well, you got to remember from the property of logarithms that if you're subtracting, you can just divide the insides left minus right. So let's rewrite that. So this whole left side, we can just rewrite it as log of 9 x plus 6 divided by x equals log of 9 of 2. Excellent. So now let's see. Now we have 2 logarithms. They have the same base. They're equal to each other, so they cancel out. So now what we have here is just x plus 6. I don't like that 6. So let's rewrite that. X plus 6 divided by x equals to 2. So how do we solve equations into this form? Well, we can put that 2 over 1, because if we do that, we can cross multiply now. So now we have x plus 6, I don't like that 6, times 1 equals, and the other cross multiplication is going to be 2 times x, which is just going to be 2x. So now x plus 6 times 1, that's just x plus 6, equals 2x. Solve for x. How do we do that? Well, let's take away this x. Let's finish our example here. So now we have 6 equals 2x minus 1x. Well, that's just x. And so we're done. X is equal to 6. 6 is equal to x. That's the same as x is equal to 6. So after all this, we found a numerical representation for x, which was equal to 6. So notice that this is the main idea here is try to make your initial equation for them to have logs equal to each other, because once they do, they cancel out, and then we can just use our Algebra 1 skills to solve for x. So here's your entrance ticket. Try to solve the following.